solve some basic systems in this class. I just want to do a couple of examples from each page, and then we'll move on. But let's start with something we haven't really done too much of, which is look at a system with fractions. Okay? So we're going to start with F. Then I'll have you guys go back and try A. Okay? What's something that we could maybe do to kind of get rid of the fractions here? What would that denominator be in the first one?
6.
Okay, so rather than actually make them all a 6 denominator, I will use that and multiply by 6. Okay, so now what happens when I multiply? What's the new equation? Half of 6 is 3x plus 2/3 times 6. You can either do 2 times 6 and then divide it by 3, or 6 divided by 3 and then times 2. Either way, you get 4. And then 6 times 4 is 24. Okay? And what could I multiply the bottom equation by to kind of make it nicer?
Eight. I know what I meant.
12. Why'd you get that?
Times 3.
Yeah. You want to cancel the 4 and the 3, so multiply by 12, right? What do we get now? 1/4 times 12 is, or 12 divided by 4, 3x, minus either 12 times 4 divided by 3 or 12 divided by 3 first, then times 4. You get 16y. And then negative 3 times 12 is negative 36. Okay. Now what would you do?
Multiply by -1.
Which one?
Doesn't really matter.
You're right, it doesn't. So let's maybe do the top one. So you get negative 3x minus 4y, negative 24, and then positive 3x minus 16y, negative 36. And since they're opposites now, you just add. And what are you going to get? Yeah, these cancel. What about here?
Yeah, 21.
Negative 20y. And then negative 24 minus 36. What does that add up to? So negative 60. So that's pretty easy. What's y?
3.
Y is 3. And now you can pick whatever equation you want. I'll maybe use this first one. So then I'll have 3x plus 4 times y, which is 3, equals 24. So 3x, if I subtract 12 over, bless you, is 12. So that means x is 4. So our solution is 4 comma 3. Okay. Any questions on that? I mean, it's what we did before, just kind of making it nicer first. Now look, some people are very particular about, writing out every step and making sure you have opposites. I'm a lazy person, so I'm going to explain it a different way. And if you think you can do it this way too, that's fine. But at least you have the option. Okay? So right here, when we got to this part of the problem, we multiplied by -1 to create opposites and then added to cancel, right? Well, 3 and 3 are the same. Anytime these numbers are already the same, the other option to cancel them out is to just subtract. So if you just subtract the two equations together, you'll get the same thing. 3x minus 3x equals 0, right? And then what's 4 minus negative 16? Just 20. 24 minus negative 36 is really just adding, so that's 60. And then right away you get y is 3, and again you can go from there. Okay? Does that make sense? All right, why don't you guys try A on your own real quick, and then we'll pick a lucky volunteer to walk us through it. All right, Ulysses, walk us through what you did. The bottom one by 2? Okay. Then what? The same equation by negative 1? So that's negative x plus 6y equals 1. Then what? So this one and this one. And you added? And so you get what? So x is 2. Plug it back in. So that'll be 4 times 2, which is 8. Minus 6y equals 5. Move the 8 over. And you should have gotten what for y then? That is correct. So 1/2, comma 2. Oh, I wrote it backwards. Thank you. 2, 1/2. Okay. Pretty good on these? Okay. Now, we didn't talk about it, but you're welcome to. You can certainly use substitution for these too, right? For example, if I looked at maybe this E equation, which of these could I use for substitution? What would I do first? There are really 4 choices, right? As far as what you want to get alone. Which would be the easiest to get alone? Yeah, this first x. Just move the 3y over, and then you can just plug it into the bottom equation. Does that make sense? Okay. Let's go on to page 2. Okay. So now we're stepping it up. So not many of you have seen 3x3 systems before, but it's the same idea. You're still looking for an intersection point. You're looking for an x, a y, and a z that will work for all the equations now. Okay? And probably the easiest way to do these is to eliminate twice, and you eliminate the same variable both times. And then you'll be left with something that you guys know how to solve. Okay? So here's what I mean. If I look at these first two equations right here, I could probably eliminate x pretty easily, right? What would I multiply by? -2, okay. So if I multiply by -2, I'm going to rewrite it. So that's -2x plus 6y minus 8z. And then that equals -18. And then this one I'll just copy down right underneath it. 2x plus y plus z equals 4. And now we can just add. When you add these two equations together, what is left? Seven y, yes. Positive or negative? -7z equals -14. I'm out of space, but that's -14 right over here. Oof. That's still, oh, that kind of looks like a 14. Okay. So there's one equation. Now I have how many variables here? Just 2. We can't really solve anything yet, but if I look at a different combination, a different pair, it doesn't matter which, but maybe first and third or second and third, and eliminate the same variable again, you'll be left with another equation with y's and z's in it, and then that one you should be able to solve now. Okay? Which two could I use to eliminate x real easily? Yeah, these two right here, perfect. Just add them up right away, right? What's left? 4y and then z plus -3 is -2z and then that equals -6. Okay. And just because I'm off the screen here, I'm going to rewrite them just so they're clearer. So here's what we're looking at right here. This you guys should be able to handle now, right? It's just a normal system. Instead of x's and y's, it's y's and z's, but we can find that. So take a minute or two, find out what y and z are. And then Willie will walk us through how to do this one. Bless you. All right, Willie, take us through what to do here. Well, we want to cancel either the y's or the z's out, right? So pick one. What do you want to cancel? Okay. How do you cancel them out? You want them to equal the same? Okay, so what can I multiply by? To cancel the z's, he wants to cancel the y's. How do I make these the same? Yeah, just 4 and 7. Okay, so what is that? Okay. All right, bottom equation.
Same thing. The first one.
Uh-huh. All right, now what? Good, so you made them the same, so we're going to subtract. So now 28 minus 28 cancels. Negative 28 minus a minus is really plus, right? So what's negative 28 plus 14? Negative 28, add 14.
Oh, add 14.
And now here we have negative 56. These are both negative, so we're adding 42. What's negative 56 plus 42? All right, so what's z? All right, so there's z. Now?
Oh, now you plug it in. Plug it in
Which one?
the top.
This one?
No, like the green.
This one.
Yeah.
Good choice. Okay. Either one will work, but this is smaller, so might as well use that one, right? So 7y, negative 7 times 1 is minus 7.
Yeah, so
Add 7. So that's negative 7. So y? Negative 1. All right, now what? We're only 2/3 of the way done.
oh my god. Okay.
But the hardest part is over with. We just need to find x now.
Plug it into that very top.
Sure. So now it'll be x minus 3 times negative 1 plus 4 times z, which is 1. So this will be x. This will be positive 3 and 4. That's 7, right? So x is 2. Okay, so there's your solution. 2, negative 1, 1. You just go alphabetical order, x, comma, y, comma, z. Okay? Does that make sense? Okay. I'll have you guys try C in a minute, but just so that the recording's shorter than it needs to be. Let's do example 3 together, the application. So if you haven't read it yet, take a minute or less, read through it, make sure you know what's what, and then we'll set it up and solve. Okay, now obviously this is going to translate into a system, you know, kind of like these over here on the front page with 2 variables. And it is a good idea to write down what the variables represent. And in order to do that, start with the question, because that'll tell you exactly what they should be. How many pounds of cashews? So let's let x equal the number of pounds of cashews. And we're mixing that with, so we want to know how many pounds of cashews and how many pounds of peanuts, right? So let's, excuse me. So that's what x and y are going to represent. And then from the information that's in the problem, we should be able to write 2 equations then, and that should help us figure out how many of each we should have. Okay? Can someone tell me one equation? Even if you're wrong, it's okay. Well, it's 5x plus equals, okay? You're so very close. That's a great start. We'll adjust it in a minute. What's another equation, though? Perfect. Okay, so x plus y equals 50. This equation down here represents the total number of pounds, right? The number of pounds from the cashews, the number of pounds from the peanuts have to give us 50 total pounds. Okay? Now, Adam, I want you to think about this, and here's kind of my clue that hopefully will help you figure this out. What does 5 represent? So the money, the price per. So you're taking the price and multiplying with the number sold, right? What about here? Price with number sold. So that should also equal price with number sold. So how many pounds were sold at $3 a pound? It's in there. 50, yeah. Does that make sense? We're selling 50 pounds total. The mixture is $3 a pound. And this is how we create it, okay? So this represents price per pound. Okay, so every equation should kind of make sense and be in the same units. If you take price times pounds, you should also be doing that on the right-hand side, okay? And now, should be hopefully straightforward to solve. How do you guys want to solve this one? Sure. Times negative 5 to the bottom one. So now that's negative 5x minus 5y minus 250. And then we're going to add top with bottom, right? So that's going to give us negative 2.5y. 3 times 50 is really 150, right? So 150 minus 250 is negative 100. Divide by negative 2.5. What's y? $40, yes. So 40 pounds there. And this is pretty easy. If x and y add up to 50, so then the x has to be 10. So your final answer would be 40 pounds. What is y? Of peanuts. And then 10 pounds of cashews. Okay? Does that make sense?